Okay, so on to the mechanics questions then. So question 4, particle of mass m kilograms. Now this is important because more than one of you are getting confused between forces and mass, so weight and mass. When we're drawing a force diagram and when we're writing out our force equations, it's really important that you're clear which is which. So we've got a particle of mass m, which means its weight is mg. It's attached at C to two light inextensible strings AC and BC. The other ends of the strings are attached to fixed points A and B on a horizontal C line. The particle hangs in equilibrium with AC and BC inclined to the horizontal at 30 and 60 degrees. Given that the tension in AC is 20, so I know that that tension there is 20, I want to work out the tension in BC. So this is BC, so I need to work out that tension there. Now the force equation, or the force equations that I'm going to produce are based around C. So I need to know these angles that are acting here. And because it's telling me that AB is horizontal, then I can extend a horizontal line down there and then use parallel line relationships, so that if that's 30, I know that that angle there is 30, and similarly that angle there is 60. Particles in equilibrium, so in equilibrium, therefore the sum of the x forces equals 0 and the sum of the y forces equals 0. I've then just got to define what's positive and negative x and y. So up on my diagram here, I'll just make that clear. Positive x is in that direction, positive y is in that direction. So if I sum my x forces, first of all, for the tension here, the x component is going to be along here. So if you imagine that I'm making a right angle triangle where that is T and that is 60, this here is going to be the adjacent to 60, so it's going to be adjacent over hypotenuse, which is cos. So I'll get T cos 60 minus 20, and this will also be cos 30, and then the weight acts entirely perpendicular to that, so it won't feature in the equation. So I'll just have T cos 60 minus 20 cos 30 equals 0. And we could just use that to calculate T, but I'm going to get, as I always advise you, all my equations written before I start to manipulate. So Fy, the vertical component will be opposite the 60, opposite is linked to sine, so that will be T sine 60 plus 20 sine 30, because that's also pulling in plus y direction, minus mg equals 0. So those are my two equations. I'll now take a little moment to decide how I can use those to work out what I need to find out. So I can manipulate equation 1 straight away to get T, and then I can substitute T into equation 2, and the only unknown I'll have is M. So from equation 1, T cos 60 will equal 20 cos 30, just taking the minus 20 over. T will be 20 cos 30 over cos 60. Okay, just check that my calculator is in degrees, which it is, D. So 20 cos 30 on the top, cos 60 on the bottom, so that's 34.6. Check, so it's 20 root 3 as a surd. So that's the tension in BC, so that's part A. And then part B, put that in 2, and I will have that mg will be 20 root 3 sine 60 plus 20 sine 30. So 20 root 3 sine 60 times answer is the 20 root 3 bit, plus 20 sine 30. So mg equals 40, m will be 40 over 9.8, which is g equals 4.1 kilograms to 2 sig fig. There you go. So that's question 4. As I mentioned, one of the common mistakes was just to have m under there, which then means that your equations are going to be wrong. Yeah, so that one's done.